the changes from the quadratic parent function. So real quick, before we start talking about quadratics, I wanted to remind you about the linear parent function, which was y equals x. You remember it was the most basic form of the line, and it could shift up or down based on the b value, or it could be steeper or flatter based on the slope. Okay, so today we're going to be talking about the quadratic parent function. The quadratic parent function is f of x equals x squared. Remember, the squared is what makes it into that U shape. It's the most basic parabola. Okay, so whenever we're talking about changes, we're going to be using the vertex form we talked about last week, y equals a times x minus h squared plus k. And that's what's going to cause the changes that we're going to see on the graph. Okay, so the parent function, it starts at the origin, it starts at 0, 0, and then on either side of that, it's going to be whatever it would be squared. So -1 squared would be 1, because -1 times -1 is 1, and then 1 squared would also be 1. So we're going to get that good symmetry that we have been seeing as we work with our parabolas. And then -2 squared will be 4, and 2 squared would also be 4. So on either side of that, we're going to see that jump up to 4, and we're going to see both sides be the same. Okay? So this is how the table is always going to look: 0, 1, 4 on both sides, and it's going to be the same exact width. So changes in the a value as we move down to the bottom part of our notes, changes in the a value cause what we call vertical stretches and compressions. So numbers that are bigger numbers, you can see bigger than 1, they stretch the graph out. So they just get long and skinny, like a rubber band stretching away from the graph. And then the numbers that are wider, that are going to be fractions, stuff like that, they get really wide, like they're getting squished down towards the x-axis. Okay, and then also we are going to have some vertical reflection. So I want you to make a note that negative a values cause reflections. Okay, because we are going to see those flip over the point that the vertex is at. Okay, so compressions this way, they will go down but still be wide, and then the stretches that are the reflections, they'll be long and skinny but pointing down. Okay, so each one of these, it goes with the one that it's above, so you can kind of see a picture of how that would look. So if you look at 2x squared, if you were to put that in your calculator, and then just kind of get like a little xy table, okay, you would have, so let's show you really quick on your calculator. You would just add a graph. And so if we looked at 2x squared and we went ahead and pulled up the table for that, okay, you can see that at 0, 0, it's still going through the origin, but instead of the next point being at 1, it stretches it up to 2, and it stretches the next point up to 4. So whenever you do that one on your graph, it will look still coming here through 0, 0, but it stretches that first point up to 2, and then the other one would stretch up even further. So it would be skinny like that. Okay. The next one, so we had 0, 0, and then 1. Instead of being at 2, is at 4. Oh, no, 2. Okay, the next one, if we look at, is going to be a compression. It's going to compress it towards the x-axis. So if we wanted to look at that in our calculator, I don't know if you guys know, but you can press tab and graph multiple graphs into your calculator. So we can do 1/3 x squared, And then when we look at the table, we can actually, you see how that one is so much fatter? We can actually look at the table to see the changes, right? So we want to have that 0 in the middle because our vertex is still at 0, 0. But you can see these are going to be, the red graph is the compression. These are all going to be decimals. So we have a point of 0, 0, but the next whole point is not until -3 and 3. So we have -3, 3, 0, 0, +3, 3. So we still come here, but we move up until to a whole number until over here. So that is just going to increase at a much slower speed. It just smushes it down towards the x-axis. Okay, and then if we had -4x², we can look at that on our calculator. It's going to be skinny also, but it's going to go the other direction because of that negative. Okay, so we have our x and our y. It's still going to have that vertex of 0, 0, but at -1, it's going to be -4, and at 1, it's going to be -4. So it still is here, but it's stretching down this way to face down. Okay, so that's where those changes are going to come from. The h and the k value are going to cause vertical and horizontal shifts. Okay, the k value is going to cause vertical shifts up and down, up or down. If you have a plus k at the end of your parentheses, if it says plus whatever the number is, it's going to be a shift up. And if you have the, after the parentheses, the -k, it's going to shift down. Okay, so this one right here, you can see x² + 1. That is going to shift this up to 0, 1. And then the points are going to be the same. It's not any skinnier or any wider. It's just starting at a little bit higher up. So if you were to look at the table for that, you would see instead of -1, 1, it would be -1, 2, 0, 1, and 1, 2. Okay, this one is going to be the minus, so it is going to shift down. So you're going to see on the table, instead of being at 0, 0, it's going to be at 0, -2. So it's going to start here. And then, probably shouldn't do that red since the parent function is red. Let's do it in blue. So whenever it shifts, the 1 is going to be, instead of being at 1, it's going to be at -1. And then 1 at -1. So they'll be here. And then the next one will be here and here. So you can see it looks a little wider, but it's really not, just starting a little bit further down. Okay, the h values are going to be horizontal shifts left or right. Okay, and we have to remember that the h is kind of opposite as far as what we are looking at. Okay, so if the h value is if this is equal to the h value, so whenever you pull this out, remember that h in this one is -3. Okay, and h here is +4. Okay, so you have to remember that it's opposite of whatever you have in the parentheses. So if we were to go to our calculator, we'll add a new document so we don't have any of those old graphs in there. And then we'll look at our parent function. So that's just the most basic guy, x². And then the next one we did x + 2, and then the squared on the outside. We know, okay, that's going to be a -2. So that's going to make it shift to the left. Okay, if it has pluses, oops, that is going to make it shift to the left. If it has a minus, that is going to make it shift to the right. Okay, so here we would have, I'm going to do this one in, let's see, this light pink color, plus 3. It's not getting any wider, it's just moving over, okay? So the h value of negative 3 would start here, go up like this, and then up here. So again, it's not any fatter or skinnier, it's just shifting one way or the other. And then the second example that we had, it said that the h value was 4. We pulled out that positive 4. So here we would shift over to the right 4. So we would start here, and then we would see that side of the graph, like that. Okay.